analysis and visualization tool for geospatial data. It runs on top of the Aristotle cloud. We have been using it to run our experiments on understanding changes in future climate simulations using machine learning algorithms. So we start by logging into the system that shows us the globe in 3D. This looks very much like what you might have seen in Google Earth or the modern Google Maps. You can also switch to a 2D setup as well. Sometimes when dealing with global data sets, it's easier to see things in 2D. So the first thing you'll see here is that we already have some data sets loaded here, and these are some data sets that are publicly available. However, this allows you to load new data sets as well. For instance, let's say we are trying to upload a new climate data set that we have, which is for now sitting in some HDFS repository. And so we enter the URL for that, and this could be anywhere. You enter some name of this data set. This particular data set is from the SIM5 project, and talks about the pressure for next to. Once you hit upload, this data set starts getting loaded up into the system. So now what will happen is, after some time, this data will get listed here, and this is still in the process of getting uploaded. But I've already uploaded one data set beforehand, which is very similar to this. This is about temperature. So what this system can now let scientists do is play around with this data. So of course you can look at the information about this, but you can also visualize this data, right? So for example, you can choose which variable you're interested in. This particular data set has only one. Right now this data that we have loaded is only for 3 years. This is daily data. So next thing you can do is that, let's say you want to look at this image or the data set as imagery. So you can click here, and once that is loaded, you can play it as an animation. Let's say you're interested in looking at how the temperature in this particular case varies over time for certain location in the world. You can bring up this particular panel, and you click on any place in the world, and the system will go back to the server in the cloud and bring this data and display it as a time series. So it looks something like this, and you can interact with this time series as well. Later on we have plans to couple this up with a server-side R environment where people can actually analyze this data. That will be more of some time series analysis routines. You can also bring in another data point and compare. Analysis interface is very similar. So here on this, instead of view, we say we want to analyze. So we bring up this interface, and this brings out the different fields that we can run this analysis on. This data set of course has only one field. It also tells you what kind of analysis you can run. So right now there are 3 algorithms that are implemented. One is a Gaussian process based change detection algorithm, works on a distributed environment within Aristotle. Another one is an anomaly detection, which also works in a distributed form, and the last one is correlation analysis. So let's say you want to run change detection. Right now we have made it so that there are no parameters to tune, but for other algorithms there might be parameters that the user can enter, and then we ask the user to give some name to this. So let's say and then the user submits this job, right? And this job gets submitted uh, onto Aristotle. They can track the progress of their job on this panel. So this particular panel shows the different jobs that are running right now. So you can refresh it, and you'll see that the job that I just submitted has come up here. You can also see how this impacts the cloud, right? So if I click here, it will take us to the Aristotle's cloud usage page, where once this job gets submitted, starts running, you will see a uptick in the usage. If it's successful, then this data will now be available to be uploaded, into this visualization interface. So I've already done that for a different analysis that I ran earlier, which is very similar to this. I ran GP change detection algorithm there as well. So now we can actually visualize that result as well. Blue means there is no change. So the way this algorithm works is that it looks at the data, and for every pixel, which is a half a degree by a half a degree cell on the globe, it tells you an assessment if it considers there is an anomalous change in the temperature or not. So blue means there's no change, yellow means that there is possibly a change, and black means that there's definitely a statistical change uh, at that location. So when we ran this for many years, what we saw was that, of course, the South Pole region shows a lot of change from day to day, which is expected, and most of the rest of the world sort of is stable, but sometimes we pick out certain interesting events when we play this animation, and those are the things that we are right now studying with our climate scientists to see what are the science related in science related reasons for that. And also visualize this data just like we did earlier by just clicking on any pixel. Right, so for example, in this particular pixel, there was no change during this time frame. Of course, if I click on certain interest, so clearly as we could see in the animation as well, this particular location has many more changes, and these are the things that are statistically coming out as an output. These might or might not be scientifically relevant, and those are the things that we would study further.